Hey guys, as our American friends would say, or welcome back to Down the Shed. So, in this experiment, we're going to be doing another Elenco 50-in-1 on the EP50 50-in-1 electronic playground. I haven't sent an email to Elenco yet, must sort that out over the last project. So this is number 6, this is quite simply a water detector. I have knocked this one up first. You've seen how electricity flows through copper wires easily and how carbon resists the flow. That'll be the resistors, carbon in them. How well does water pass through electricity? Well, let's find out. Connect the wires according to the wiring checklist and take a look at the schematic. There isn't a switch this time, so just disconnect one of the wires if you want to turn the circuit off. Notice that the wiring checklist leaves 2 wires unconnected. The LED, it's wiring the blue one, will be off initially. If you touch the 2 loose wires together, then it will come on, completing the circuit. Now take a small cup, make sure it isn't made of metal, fill it halfway with water and place the 2 unconnected wires into the water without touching each other. The LED should now be dimly lit, but the brightness could vary depending on your local water quality. I think it's pretty shite around here, but it does come on quite bright. You are now seeing a demonstration of how water passes through electricity. A small cup of water like this may be around 100k ohms, but depends on the local water quality. Try adding more water to the cup and see if the LED brightness changes. It should get brighter because we're making the water pipe larger. It doesn't really actually make any difference in my initial experiment. Since the LED only lights when it's in water now, you could use this circuit as a water detector. So for example, you could knock something up like this, 2 wires on the side of the bath, perhaps to a speaker or something, and then when the bath water gets to the level that you desire, you've got a little water alarm. So let's crack on and build the circuit. So we want to wire 27, which is battery positive, to 41. That should reach, yeah, it will. 40 to 39, so a little short one. So that's the 1k connected to the 470 ohm. 44 to 42, so another little short one. 42 to 38. That's the 3.3k connected up to the 470 ohm. And 38 to 3, so we're going up to the LED. Four is unconnected, so we'll get a long wire. So the LED positive is unconnected, which is going to make the circuit. 26 to 45, so the battery negative to the other side of the 10k. 45 to 43, 10k back to the 3.3, so they're in parallel, I think. And 43 is the other side of the unconnected long wire. So initially what will happen if we touch the 2 wires is we've completed the circuit, like so. So I'll kill some lights for that. I'll reconnect the 2 wires, or retouch the 2 wires to make the connection, completing the circuit, and there we have the LED. So now what we'll do is we'll get a glass tumbler. I'll bring this over to one side slightly, bring the glass tumbler in, and we'll half fill that with water. This isn't spring water, this is basically straight out of a good old Wiltshire tap. We'll stick that side of the wire in and we'll put a bend in it to try and hold it in place. Now when I dip this side in, we should see the LED light. And there you go. So we're not touching the wires together, we're literally just dipping it into the water. So it does say if we fill the glass, increasing the length of the pipe, that should get brighter. I don't think it does, but we'll do it. And there you go. I don't think that is any brighter at all, you'll agree. So let's continue. I'll turn this little light on. And that really flipping kills the impact onto the LED. So now adjust the amount of water so the LED is dimly lit. Now watching the LED brightness, add some table salt to the water and stir to dissolve the salts. The LED should become brighter because water has a lower electrical resistance when salt is dissolved in it. Looking at the water pipe diagram, you can think of this as a strong cleaner dissolving paintballs that are mixed in with the rocks. You could even use this circuit to detect salt water like in the ocean. So, yeah, nice one watch. So what we should do is throw the water out of the shed. So kill the light. Let's get the wires back into the water. It possibly does look a bit dimmer. So what I shall now do is get some salt, and hopefully the camera may pick up an increase in brightness, but I haven't done this once already. I don't think it does. And I don't think that made any difference to, and that is quite a salty solution because the water hasn't gone clear again. So that's experiment number 6, the water detector. Nice simple experiment. Could have, and I'll just show you, there you go, it's quite a salty solution in the glass. So I don't believe the salt made much difference there. It could be something to do with my local water quality, who knows, but it worked. So that, again, as I said, that could be anything, you know, ranging from a bath water or a sink. You could have it outside your house on the roof, so when the rain started hitting both wires, you knew it started raining for any reason. But a little simple circuit with many possible applications. So thanks for watching the video. Let's turn this light on for a minute. Thanks for watching the video. Like the video, subscribe to my channel for more of the Elenco 50-in-1 electronic playground learning kits. I shall just quickly show you the diagrams to the camera. So there's the schematic. There's the water diagram, or the water diagram analogy. And I'll start showing you these as well. And there's the wiring diagram, just in case you manage to get hold of one of these kits without a manual. Okay, and the car battery needs a good charge outside, need more solar power. So that's it for this video, and I shall, in the next video, I shall basically go through the introduction to capacitors, and the video following that we shall do the slow light bulb. So again, thanks for watching, and I'll see you in the next one, guys.